Okay, we're going to finish up the last example of our Chapter 17 HIJ notes. This will finish out all of Chapter 17 for us. For the last question, it says a farmer has 20 meters of fencing to create a rectangular enclosure X meters long alongside a barn. So what we have, and that's pretty vague, but this is what it means. We have a barn, and we want to create a fence off of this barn, like an enclosure like this. He has 20 meters of fencing in total, so the barn accounts for this side, and then this blue line here needs to account for 20 meters of fencing. These sides are X long, and they want us to write an expression for the area. So for the area of a rectangle, our area of a rectangle is length times width. We know that we have a width of X, but we need to figure out our length. So if we have 20 meters of fencing total, and we need to use, all three sides, we know these sides are both X, so this side will be 20 minus however long these two sides are, so minus 2X. So if this is X and this is X, and we have 20 total, then this side is the total of 20, take away both of these sides, so minus 2X. To write an expression for the area, we have a length of 20 minus 2X and a width of X, so we multiply those together. Since it doesn't specify what type of expression, you could leave it like that. Additionally, we could write it as 20x minus 2x squared by distributing the x into the parentheses. In order to maximize the area he can fence, we want to know the maximum value for A. So we want this. I'm going to graph this and see where the maximum value occurs. So I'm going to go to my y equals, and I'm going to graph 20x minus 2x squared. My y is my area. A is y in this case, and I want to see what would make y the biggest. So when I graph it, I have a parabola. Well, you can't really see it. I should have a parabola. If I zoom out, you can kind of see the shape now. If you zoom out one more time, maybe you zoom out up a little bit higher. It's hard to see. So why don't I change my, let's see, maybe let's go back to zoom standard. I'm just messing with the zoom button to try to figure out how to view this best. We could zoom. I'm going to go, before I zoom out, I'm going to scroll up. So I'm zooming out relatively like up above like this. That works pretty good. Okay, so there's my parabola. My maximum area is going to happen up here. That's the maximum value for y. That's our maximum output. If you look in the table, we might be able to get close. Oh, and there we go. That's actually it right there. So 550 is our maximum area. Additionally, if it doesn't show up in the table, then you could use second calculate maximum. You go to the left side of the max, over around the maximum to the other side, and it also tells us that when x is pretty much 5, y is 50. So what is the maximum area he can fence? Well, 50 would be the maximum A. In this case, we are in meters. So 50 square meters. His best bet, the best thing he could do to make the most area would be to make x 5. And that would end up making this 20 minus 2 times 5, 20 minus 10, which is 10, and he would enclose an area of 50. Everything less than that, everything different than 5 makes a little bit smaller area. All right, this finishes up Chapter 17. Your homework assignment you can view on Canvas, so you know what to work on. And thanks for listening.